In this lesson, we're going to take a look at parallel lines, what they are, what they mean, what do the equations that create them look like. Parallel lines have a shorthand notation that is 2 forward slashes that look like, well, parallel lines. Parallel lines are lines that are graphed on the same plane, or in essence the same sheet of paper, two-dimensional, that never intersect. They'll never cross, they'll never touch. Let's do a small investigation. We want to graph all the given lines, there's 4 of them, on the same graph. And we're going to take a look at how those lines compare and what information we can gather from them. All these equations are given in slope-intercept form. Each one has a slope and intercept. That was yesterday's activity and lesson, so we'll use that to practice doing it today. The first equation has a y-intercept of 3 that says you cross the y-axis at 0, 3. From this point, we'll count the slope up 3 over 4. So we'll 1, 2, 3 units over 1, 2, 3, 4 units. There's our point. Once we have both points, simply connect the dots to graph the line. Remember, all of our lines should have arrows on them. And I can end up putting 4 lines on this graph, and I want to know which came from where, so we're going to label it. It means I'm simply going to write the equation on the line that generated it. Y equals 3/4 x plus 3. On to the next one. Y equals 5/2 x minus 6. -6 is our y-intercept. Down 1, 2, 3, 4, 5, 6 units. And that is our y-intercept. From this point, we use the slope. It says go up 5 and over 2. Up 1, 2, 3, 4, 5 units over 2. We have our 2 points. Connect the dots. Label it. Y equals 5/2 x minus 6. Line 2 is done. Line 3. I'm not adding anything. That's a plus 0. 5/2 x plus 0. So y-intercept is 0. It's at the origin. From this point, it says go up 5 over 2. Up 1, 2, 3, 4, 5 over 1, 2 units. And you could, if you wanted, do the exact same thing in the opposite way. Go down 5. 1, 2, 3, 4, 5. Go back 2 units. And what you'll find is all 3 points will be on the same line. It only took half a second to do the second point. And it gave me nice accuracy having 3 points to be sure I graphed my line correctly. Put arrows on there. Label it. Y equals 5/2 x plus 0. Last one. Y-intercept at -1. Slope is 3/4. From here, go up 3 over 4. I can go down 3 and backwards 4 as well. Connect the dots. Arrows. Label it. 3/4 x minus 1. And that's the power of slope-intercept form. It let us graph these 4 lines very quickly. Now, remember the concept is parallel lines. They're 2 lines that never touch. I see several intersection points. So these 2 lines would not be parallel because they intersect. these two lines would not be parallel. They intersect. Same thing down here. But I'm noticing those two lines do not touch. I'm noticing these two lines do not touch and look like they never will. These are my parallel lines. So the question is, what do these two pairs of parallel lines have in common? What's making this happen? Little observation here. Take a look at your first two. 3/4 x plus 3, 3/4 x minus 1. What do they have in common? 3/4 x. They share the same slope. They share the same angle. Look here, other pair of equations. 5/2 x, 5/2 x minus 6. Once again, those two lines share the same slope as each other. Those two lines are parallel. So this little investigation has given us all the observations we need to determine that parallel lines have the same slope. And that's the big idea, same slope. So if you are ever asked to determine if two lines are parallel or not, simply find their slopes and observe, are they equal or are they not? If they are equal or if they are the same slope, they're going to be parallel. That's all you need to know for parallel lines.